All right, so today we are dealing with tests for difference in two sample proportions as opposed to interval that we dealt with on Friday. So anytime we are running a test, you are finding everything based on what claimed idea. So for a two sample proportion, at least very generally, what do you think it's going to look like for a null hypothesis? Don't overthink it. Something, right? But what's always in our null hypothesis? So, some number. Sometimes we pick a specific number there, which would make sense, like I want to convince someone to buy my product, and my product is improving some success rate, and I can prove through a statistical test that it improves the success rate by at least 10%. Like that would make sense why to put a number in there. Why would it make sense to put 0 there? We think that they're the same or different. So we don't know which direction. We don't have a specific amount to change it by. We want to see if they're the same or different. So that would be if it changes 0. For the sake of this class, for the most part, we pretty much always deal with 0. But you might see one that's something that's not 0. So if we are testing that the difference is 0, so P1 minus P2 equals 0, which is how we'll write ours. But algebraically, this is the same thing as saying what? What? Yes, but what is the really easy, obvious thing that's going on right here?
Just
Right? So when we write a test, we're usually going to write it this way, but you'll see things like a multiple choice question where it'll show this, which is algebraically the same thing. So basically our claim here is that the two proportions are the same. So don't read everything that I'm writing yet. In a proportion with means, how do we calculate the standard deviation of a statistic in general? It's one of the two. What does that equal? Right, so the way I find the standard deviation portion of the equation is I need to know this other variable called standard deviation, also relative to the sample size, right? When I am dealing with proportion and not talking about specifics, just very, very generally, what is the equation? So I don't have this other variable called standard deviation. I'm using proportion, which is what I'm already talking about here, right? So here I'm claiming that they're the same. I'm using that to figure out standard deviation, which means if I'm claiming that these are the same, I'm claiming that like the standard deviation portion is also the same, right? Because it's only coming from that one variable. So we have to do an extra thing here because of that. So standard deviation of the statistic uses the claimed proportion, something up here, to calculate the value of the sigma p hat, which is what we just talked about, as opposed to where population standard deviation, this other variable, is used when we deal with means. So if we're already claiming that the difference in the two proportions is 0, then we are saying that they are what? The same. Then that means we're also claiming that their standard deviation of the statistic is the same relative to the sample size. That's the divided by square root part. So if we are testing the difference to be 0, we're actually claiming they're the same. then we have to use this thing called a pooled sample statistic. And above pooled, if you have room, I want you to write combined. So it's called pooled, but P hat P gets kind of funny. So it's P hat C. Alright, so don't write what I'm writing. Let's say I'm claiming that the proportion in sample 1 blue is the same as the proportion in sample 2 blue. So what is my best guess at what the overall proportion of blue is? How can I come up with that? I can't pick just this one because say that one's better. I can't pick just this one and say that one's better, so what can I do? What do you mean by add what? So here, so how many total successes do I have? And what else do I need to know? Trials. So how many trials did we have in sample 1? How many trials did we have in sample 2? So that is actually my best guess at what the actual population proportion is, right? So this is a pooled proportion. So how do I find P hat C? You just told me how to do it. Let's put it in symbols. So 4 and 7 that I added together, what are those? What do we usually call those?
Successes.
Yeah, what? If I have one variable for number of successes, it's what? So I have x1 plus x2, and I divided that by what plus what? N1 plus N2. So I'm claiming that they're the same. So I have to use that they're the same in calculating the standard deviation portion. So I use that to figure out what my best guess of the actual proportion is to use in the standard deviation portion. So now, in the standard deviation proportion, the combined part, I'm going to have P hat C times 1 minus P hat C. But with my example, what was really different about the two samples? The number of trials. So I'm going to do this one relative to how many trials I have. So I just changed the top to P hat C. But I'm still combining them. Well, what do I always do when I combine standard deviations? And I went through variance to get them. That's why the standard deviations are, or the square roots are the whole thing. And then so what's this one going to look like? Now, I think it makes sense explaining the way I went through it is we're already claiming that they're the same. So when we're claiming they're the same, we have to use that they're the same in the standard deviation, right? Now, the textbook here, and this is basically for the level that we need to know for this class. So if we are dealing with a test, which means we have a claim and we have to say that the claim is true, we need something to put there. So anytime we are running a test, we're using p hat c in this portion of the equation. I think it makes more sense to think through about why it would make sense because they're the same and you're claiming they're the same. But a lot of this has to do with the fact that we so rarely deal with anything other than 0 that for the extent that we need to deal with it, it's kind of easier to do it this way. I am not going to give you anything on a test that is p hat 1 minus p hat 2 equals something other than 0. Unless maybe I gave it to you as like a multiple choice and it was like an obvious kind of thing, which is where I think for the most part that if you saw it on the AP exam is where it would be. I don't expect you to see much of that. Alright, so just thinking through this part, which we shouldn't really need to write, it should be pretty obvious. Let's say I'm going to deal with this is my null hypothesis. So if we're testing to see if P1 is higher, that's where we're testing, and that means we have a bigger number minus a smaller number. And if we have a bigger number minus a smaller number, that's going to result in a what kind of number? Which means our alternative would be that P1 minus P2 is what? What gives me a positive number? Greater than 0. As opposed to if I had already written it like this, and P1, we're testing to see if P1 is lower, then I have a small number minus a big number, which is going to result in a what kind of number? Which means my alternative would be less than 0. I'm hoping this looks very obvious to most people. But I had space to write it in my direct. So the big thing is, and you might even want to write this somewhere at the bottom, so only with tests are we using p hat c, which is the pooled proportion or combined proportion. We don't have anything to claim about it. We don't have to put it together.